Question number 16. A system of equations. The real goal when thinking about a system of equations is when you have an x and a y, what they want you to know is you have a graph. I don't know what this graph looks like. I'm just making this up so you're aware. But I'm going to come in here and I'm going to say, okay, I have a picture of a line. And then I have a picture of another line. I just want to know where they cross. Okay. If you wanted me to show you on Desmos what these exact lines look like, Desmos is a wonderful tool. Again, they actually want you to do the math here, but I'm always going to step away and say, hey, we have the answers. We need to test our x comma y in for our answers. I'm going to do every single one, but we're just going to start at the very top. They're saying x is 1, y is 10. I can replace x and y and see if that's going to get me the number 15. For terms of organization, I'm going to come over here and I'm just going to make a little chart and I'm going to call this equation 1, equation 2. And once I know it works and doesn't work in one of them, I'm done. You know what I'm saying? Like I can cross that out. If I need to come back at the end, I'll come back at the end. So equation 1, equation 2. So if I'm looking at the very first one, okay, x is 1. 2 times 1 is 2. 5 times 10. Well, 5 times 10 is 50. Okay, so is 2 minus 50 going to be 15? This one's out. First one's already done. When we look at question 2, we see 25 over 2. They want to scare you on that. That means 25 divided by 2. I'm just going to come right over that right now, and I'm going to say, hey, that's 12.5. I'm okay with 12.5. That means x is 2 times 12.5. That's 25. I'm going to put a little math over here. 25, and we're going to minus what says 5 times 2. 5 times 2 is 10. 25 minus 10, that's 15. I'm going to say yes. I know it works there. Okay, so let's try equation 2 with those same numbers because it's got to work there too in order for it to be the perfect spot where the two lines cross. Okay, so that means that that point for the record that we just did, 12.52, that's on the first line. If it's on the second line, that's where they cross at that one unique spot. Okay, so I'm going to take 3 times 12.5 and I get 37.5. 37.5. And then 7 times 2. So 7 times 2 is 14. And if I subtract those numbers, am I going to get 23? I don't know here. 37.5 minus 14. It's close, but it's not right. So this is also going to be a no. Let's try the next one. X is 10. 2 times 10 is really going to be the number 20. And 5 times 1 is going to be the number 5. So 20 minus 5, hey, that is 15. So that's also a yes. That's another point on that line. What about the one below? 3 times 10, we know that. That's really 30, right? Three $10 bills. And then 7 times 1 is 7, and it says to subtract. And 30 minus 7 is 23. I'm done right there, and I can move on. That is my answer. For practice, I'll show you the last two just to show you that they're not right. But 2 times 5 is 10. We knew that from before. And then 5 times 1 is 5. Is 10 minus 5 going to be 15? Nope. So once I know that one, I don't have to test the other one once I know I have it wrong. And again, that last one, they try and catch you with these fractions. 35 divided by 4. Okay, that's just 8.75. Again, we can put that in 8.75 times 2. We get the number 17.5. And we take the number 0.5 and we times it by 5. I know that number is already written, 2.5. But 17.5 minus 2.5, that is true. It is 15. So this is actually a yes. So now we have to plug it in the bottom. We know it's going to be no. We knew that was our answer, but let's show why. Again, 8.75. I have to now times it by the number 3. I get 26.25. and I got to take half of 7. 7 times zero point 0.5 is 3.5. And if I subtract there, I'm not going to get 23. Again, it could be close. In this case, it's not that close, but this part was false. So it has to be a yes and a yes in both equations in order for it to be true. Keep up the hard work.